In the second class of Chapter 6 of the course of Basic Geometry are presented the formulas of the relations between the elements of the triangle of the side of a polygon. Formulas of relationships between elements of the triangle at the side. Table of values for the central angle, sine and cosine. Sum of the external angles of a polygon. Sum of internal angles of a polygon. Number of diagonals of a polygon, values of angles in a regular polygon. In this first slide of the second class of Chapter 6 of this course of Basic Geometry is presented the figure 6.5 that shows a circumscribed circumference and the side triangle. In the study of geometry, the use of trigonometric formulas should be avoided, such that technology is the reason of studies of the area of mathematics known as trigonometry. Whenever possible, constructs based on the properties and postulates of geometry must be used, and the calculation of areas and perimeters must use the formulas derived from the constructions themselves. But in this Chapter 6 of the course of Basic Geometry, we studied regular polygons of 3 to 12 sides. Polygons with 7, 9, and 11 sides are not possible to make the construction exactly, only approximately, so that it's necessary to use in this case some trigonometric formulas. This slide shows the calculation methods of the perimeter and the areas that will be used for the particular case of the three polygons mentioned in the previous slide that have 7, 9, and 11 sides, in which cannot be accurately constructed. To ensure the accuracy of the calculations in this case, the sine and cosine values of trigonometric are used. To assist in the study, in figure 6.5, the concept of sine and cosine is presented for an angle with the values s divided by 2, that is, an angle with value half of the value of the central angle s, corresponding to the side of the polygon. The figure shows the side triangle of a polygon that has by side the straight line segment DF. The center angle has the value s. To define the concept of sine and cosine, the straight line segment CE, the straight line segment DE, and the radius R are used. The angle to be studied is the half angle of the S angle, that is, the angle S divided by 2. A zero value angle will be composed of the straight line segment CB and another straight line segment CB superimposed on the segment of the aforementioned line CB. This slide presents the concept of sine and cosine for the angle S divided by 2. The sine of the S divided by 2 angle, which is formed by the straight line segment CE and the radius R, has a value equal to the dimension of the straight line segment DE, which has a value equal to the dimension of the side divided by 2, and divided by the dimension value of the straight line segment CD, which is the radius of the circumference. The cosine of the same angle S divided by 2, formed by the straight line segment CE and the radius R, has a value equal to the value of the dimension of the straight line segment CE divided by the value of the dimension of the straight line segment CD, which is the radius of the circumference. If the radius dimension is considered the unit, the tabulated value for sine and cosine for the various angles is the dimension of the straight line segments DE and CE. In this slide are shown the formulas for calculating the area of the side triangle, the total area of the regular polygon, and the perimeter of the same polygon. That is, if the values of the side and the apothem are known with respect to the radius of the circumscribed circumference, all other values of the polygon will be also known. As previously mentioned, The values of sine and cosine will be used only in cases where the exact calculation is not possible, using the structures and constructions of the basic geometry. In this slide is presented the table that shows the values for the sine and cosine of the angle S divided by 2 that has the value half of the value of the central angle S of the polygons. The center angle has a value of 360 degrees divided by the number of sides of the polygon. This slide shows the calculation of the sum of the external angles of any polygon. For a given polygon, the sum of external angles is initialized with the value of the external angle of a given vertex, and then the value of the external angle of the next vertex is added in a direction, for example, the right direction, continue until the last vertex. We have that the station of the side of the first vertex made a complete rotation of 360 degrees. That is, the sum of the values of all the external angles of a polygon is 360 degrees. This slide shows the formula for the calculation the sum of the internal angles